For over a century, the most trusted food scientists in the world had the wrong answer. Swiss cheese, one of the most analyzed and documented foods in modern history, was hiding a secret that nobody stopped to question. The explanation printed in textbooks, taught in universities, and accepted without challenge for more than 100 years was fundamentally incomplete. What actually creates those iconic holes had very little to do with the science the world believed. And the real answer was hiding in something so ordinary that it disappeared from dairy farms decades ago, quietly taking the holes with it, proving that even the most entrenched scientific consensus can be wrong for a very long time. Swiss cheese is technically called Emmental, named after the Em Valley in Switzerland, where it has been continuously produced since at least the 13th century. The holes inside, referred to in the professional cheese industry as eyes, are not simply decorative. They are the defining characteristic of the product, so fundamental to its identity that Switzerland's entire international reputation in dairy is built around them. For generations of farmers and cheesemakers working these mountain valleys, those holes were simply part of what the cheese did during aging, accepted as natural and never seriously challenged. It was only when food science began formally organizing in the early 20th century that researchers started asking the question that should have been asked centuries earlier. Why do the holes form in the first place? Understanding the history of that question is just as important as understanding the answer. The answer scientists settled on seemed airtight. A strain of bacteria called Propionibacterium freudenreichii, widely referred to as Propionibacterium shermanii throughout most of the 20th century, was found to be highly active inside aging Swiss cheese. These bacteria consumed lactic acid during fermentation and released carbon dioxide gas as a direct byproduct. Inside the dense, compact structure of the curd, that gas had nowhere to escape, so it collected in isolated pockets, expanding slowly over weeks and months of aging to create the characteristic round holes that define the cheese. The theory was backed by laboratory evidence, published in peer-reviewed academic papers, and written into the official curriculum of dairy science programs at major universities around the world. It became one of those facts that simply stopped being questioned, an established foundation so widely distributed and so deeply embedded that challenging it seemed almost pointless. For over 100 years, nobody looked deeper, and nobody had a compelling reason to. Before we get into what researchers finally uncovered in 2015, the moment that unraveled 100 years of accepted science, hit the like button and subscribe to the channel right now. These in-depth investigations take serious research to put together, and every like and subscription directly helps us keep going. We are just getting to the part where everything the textbooks said falls apart. In 2015, a team of scientists at the Agroscope Institute for Food Sciences in Bern, Switzerland, published findings that quietly reshuffled the foundations of dairy science. After conducting a carefully controlled series of experiments, they concluded that bacteria were not the primary driver of hole formation in Swiss cheese. The real mechanism was something else entirely, and almost embarrassingly simple. Tiny particles of hay, microscopic organic fragments that naturally drifted into fresh milk during traditional hand milking using open wooden pails in hay-filled barns, were the actual seeds of every hole. During the aging process, these invisible specks acted as nucleation points, small physical anchors around which gas could gather, and a concentrated pocket could begin to expand. Without them, gas dispersed too evenly through the curd to form a defined eye. The research team tested this directly, comparing wheels made from carefully filtered milk against wheels made from milk containing only trace amounts of hay dust. The results were not ambiguous or open to interpretation. The particles determined whether holes formed at all, how large they grew over time, and how evenly they distributed across the finished wheel. The reason this discovery came so late is arguably the most illuminating part of the entire story. Traditional Swiss dairy farming was built around open wooden buckets. Farmers milked cows by hand inside barns packed with hay and straw, and microscopic particles from that environment inevitably drifted down into the fresh milk before it was transported to the dairy. This had been happening continuously for centuries, long before food science existed as a formal field, and long before anyone thought to question the organic composition of the milk itself. When industrialized milking arrived in the 20th century, farms adopted closed, mechanized pipeline systems specifically designed to eliminate contamination. The open pails were removed, the milk was isolated from the barn environment, and quietly, over the following decades, the holes in Swiss cheese began to shrink and disappear. Producers noticed it. Commercial buyers and importers noticed it. Wheels coming out of modern Swiss production facilities were developing fewer eyes, smaller eyes, and in some documented cases, almost none at all. For years, this gradual disappearance was attributed to changes in bacterial starter cultures, differences in pasteurization protocols, or variations in aging room temperatures. Nobody connected the declining holes to the absence of hay particles because nobody understood that those particles played any functional role in the first place. The evidence was written into every wheel of cheese coming out of Swiss dairies, but the established textbook answer was so deeply embedded that no one read the signal correctly for decades. The 2015 Agroscope study did not simply fix a minor error in a reference book. It forced a broader and more uncomfortable conversation about how established scientific frameworks handle their own foundational assumptions. Propionibacterium freudenreichii still plays a genuine role in Swiss cheese fermentation. That part of the original century-old theory was not fabricated or baseless, but it was never the primary mechanism behind hole formation. The two processes shared the same environment, and researchers conflated their presence with their functional role for well over 100 years. This kind of error, confusing correlation with causation simply because two factors coexist in the same space, is more common in scientific history than most people are comfortable acknowledging. What makes the Swiss cheese case so instructive is the combination of how long the wrong answer persisted unchallenged, how broadly it was distributed across the global academic community, and how straightforward the corrective evidence turned out to be. 2 batches of cheese, one with filtered milk, one with trace organic hay particles. The results required no complicated interpretation. The answer had been sitting in a Swiss barn for 800 years, and it took until 2015 for anyone to think to look for it there. The scientific correction did not stay confined to academic papers. Today, some of Switzerland's most traditional Emmental producers have begun deliberately reintroducing controlled amounts of hay dust into their milk, specifically to restore the classic visual appearance of the cheese that modern industrial systems inadvertently erased. Something that was treated for decades as an accidental contamination risk, an impurity to be eliminated by modern hygiene standards, is now being carefully added back as a functional ingredient with a measurable and documented effect on the final product. The industry response was not embarrassment or resistance, it was adaptation, which is exactly what good science makes possible. The appearance of Swiss cheese, the size and distribution of its eyes, and the visual identity of a product that has represented an entire nation's dairy tradition for centuries all trace back to something as simple and ancient as loose hay falling into an open wooden pail. The iconic look of Swiss cheese was never engineered or deliberately designed. It was a quiet, accidental byproduct of the way people lived and worked for hundreds of years, preserved in the structure of the food itself, and waiting 8 centuries to be understood. If this kind of investigation interests you, the hidden history behind the food we eat, the science that spent a century getting it wrong, and the moments that finally set the record straight, you are exactly where you belong. Hit the like button right now if you learned something new today. Subscribe so you do not miss what we uncover next. And drop a comment below telling us which food mystery you want us to dig into. The history of what we eat is stranger and more fascinating than most people realize, and we are only just getting started.